So seventh grade, this is for lessons 19 and 20. This is factors and GCFs. So I'll always encourage, you're going to get more out of this if you pause the video sometimes and see if you can retrieve some facts from your brain. So I'll lead off with a few questions here. And you can see if you can do any of this yourself at all and then resume the explanations after you unpause. I think you'll get more out of that. So the questions I'd pose if you were here would be, does anybody remember what factors are? Could anybody make me a list of the factors of 8? Does anybody remember what GCFs are? Could anybody do the GCF of 8 and 12? And maybe pause the video now and see if you can retrieve any of that kind of information. What's the GCF 8 and 12? What GCF even means? List the factors of 8, what factors even mean, and then come on back with us, and then I'll hit through this in a second. Factors, what they are factors are numbers that can evenly divide into other numbers. So when I'm asking you to find the factors of 8, I'm asking you to list every number that can go into 8. 1 can go into 8, 2 can go into 8, but 3 can't, 4 can, 5 and 6 and 7 can't evenly, but 8 can. Those are the factors of 8. If you think you now have a better understanding of how to do the factors of 8, why don't you work through, take a second, pause the video, and work through factors of 10, factors of 12, factors of 16. See if you can do that without me with just that little bit of knowledge. If not, I'll explain it as soon as you're back with me. So go ahead and try to take those on if you can. The factors of 10 are going to be 1, 2, 5, and 10. If you drew a blank on these, now maybe that's enough to work forward. If not, I'll throw some more information your way. Factors almost always come in pairs. So on this, 2 times 5, that's one way to make 10. 1 times 10, that's another way to make 10. One way you can do these factors is by just thinking back to your flashcard times table days and thinking, what has ever made 10 before? And there's a couple ways you can make 10. That's that. Try 12 if you didn't yet. For 12, 1 goes into 12 times. 2 is partnered with 6. 2 times 6 makes 12. And also 3 times 4 makes 12. Every number's pretty much always going to have a partner of some sort. You can check your factor list usually by just making sure the numbers pair off. Littlest with biggest, next with next, inside with inside. Those are all the ways you can multiply to make 12. So those are all the numbers that can divide into 12. If you didn't do 16 yet, 16 is why I say the numbers almost always have partners. The factors of 16 are 1, 2, 4, 8, and 16. I said almost always have partners because in this case 4 is like its own partner. 1 times 16 makes 16. 2 times 8 makes 16. 4 times itself makes 16. 4 is its own partner. So that's a little bit of a different kind of thing. There's a couple things that are always true about these lists. So maybe pause the video for a couple seconds and see if you can realize, other than them coming in pairs almost always, there's 2 alwayses. There's 2 things that always happen in factor lists. So pause it, think, rejoin me. The 2 things that always happen in factor lists is that 1 is always the lowest number to start your list, and then the number itself is always the biggest number that can finish your list. Your list isn't wrong if you don't go from smallest to greatest, but it's a whole lot easier to grade these when we all put them in the same order. If we were in class saying them out loud to help each other when we go through homework, it's a whole lot easier if we all wrote 1, 2, 3, 4, 6, 12 and have that read in that order than if some kid in class reads their answer and says, I got 3, 12, 4, 6, 1, 2. And you're like, wait, what? What did you get? What were those again? We'd have to repeat it like 100 times, right? So if you can't always list them from 1 up, go for it. Another thing we could say is that 2 is a factor anytime you have an even number. Anytime there's an even number, 2 will be a factor. You might remember some of your dividing rules from elementary books. Anything that ends in 0 or 5, 5 should go on the list. There's different rules like that, but we'll go through those another day. But for now, we're just making those lists. Over to GCFs. If you didn't have a chance to reflect on GCFs, here's another chance to pause the video and think through your GCFs. GCF stands for Greatest Common Factor. It's an acronym. An acronym is when you take words and you grab the first letter of each and you make a new sort of word out of it. The greatest common factor is the biggest number that divides evenly into all the numbers in some kind of a list that you're given. So when I'm asking you for the GCF of 8 and 12, I'm asking you for the biggest number that can evenly divide into both of those numbers. One way you could do this is to build a list for each number. So I'm going to slightly walk left to just illustrate this. We did a moment ago the factors of 8. We did a moment ago the factors of 12. So if I want to do the greatest common factor of 8 and 12, I could look back at these lists. 1 is in both lists. That's a common factor, but that's not the answer. Because 2 is in both lists. So that's a better answer, but it's not right. Because 4 is in both lists, and that's the biggest number that made both lists, so the greatest common factor of 8 and 12 is 4. 4 is the GCF, 4 is the biggest number that goes into everything on that list. If you think you get that a little bit better now, go ahead and punch through the rest of these problems. 1, 2, 3, 4, 5, there's 6 of them. You can pause the video, work on those 6, see if you got it, rejoin me and I'll explain what they are. With 9 and 12, it's 3 that's the biggest thing. I would start off just thinking times tables maybe, where do 9 and 12 happens in your times tables. If you count by 3s, you're going to encounter 9 and 12 both along the way. That makes 3 potentially be the answer. Another way you could do this is make lists. The only stuff that goes into 9 is 1, 3, 9. To go into 12, the biggest one of that was 3. 3 goes into 12, so there we go. If you don't want to make both factor lists, you could save some time by just make the factor list for the littler number, because it's usually a littler factor list, and then just pick the biggest one from that list that can work for the other one. 9 can't go into 12, but 3 did. For this, I'd go with 6. If I wanted to make a factor list for 18, that's 1, 2, 3, 6, 9, 18. 18 won't go into 30. 9 won't go into 30. 6 does go into 30, so 6 is the greatest common factor. It's the biggest number that goes into both. If you just had 3 a second ago, here's a way you could check the 3 and know that it was wrong. Take the 3 that you think is right. Divide 3 into 18 goes 6. Divide 3 into 30. 3 into 30 goes 10. Take these results and ask yourself, can anything still go into both of those? And the answer here is yes. 2 goes into both of these. That makes this wrong, and you multiply by 2. If you didn't understand that, that's okay. You can live without that. Make the factor lists. That would always work out for you. Or you can instant replay it and see if you get what I'm saying. With 30 and 60, the GCF would be 30. If the littler number goes into the bigger number, that littler number is the GCF. Okay? The biggest factor of 30 is 30, and it can go into 60, and that's your answer. If you had something smaller than 30, I'll run that check again as an instant replay. Let's say you thought maybe 10 was the answer, because 10 does go into those, so 10's not bad. Okay, 10 into 30 goes 3. 10 into 60 goes 6. Ask yourself, can anything go into both of those? Yes, 3. That makes this wrong, and you multiply by 3. That would be another way we could land on the 30. 48 and 60, I'm going with 12. If I want to check if 12 is correct, 12 into 48 goes 4. 12 into 60 goes 5. And then I'd ask myself, can anything go into both 4 and 5? No, not really, only 1, and 1 goes into everything, so that doesn't really even count. Nothing can go into both 4 and 5 that helps us. That means 12 is correct. If you have trouble coming up with the 12, here's some suggestions again of how you could do it, and you just go with what works best for you. Think about, where have I seen these in my times tables? Okay, if you've super memorized your times tables, you might be able to come up with, hey, 48 was in the 12 tables, 60 was in the 12 tables. Since they're both in the 12 tables, 12 is probably my answer. Or take the littler number and list the numbers that go into 48. 1 with 48, 2 with 24, 3 with 16, didn't space myself out well enough, 4 with 12. Start to make a list. The biggest one is what you want. 48 can't go into 60. 24 won't evenly go into 60. You can divide that to try it. 24 into 60, no, it won't go. 16 into 60, you can try it. It won't go. 12 into 60 will go, so 12 is your hit. This one you might have done for a little while if you didn't yet and think, nothing goes into both of these. Yeah, huh? Now, if you get yourself in a dead-end seemingly kind of situation, what can always bail you out is 1. The GCF has to always be findable because 1 can always go into everything. If you made a list of what goes into 32, if you made a list of what goes into 35, 1 makes every list. 1 is the only thing that can go into both of those. If you get 3 numbers, I'd continue to just do the same process. Think about, where have I seen these in my times tables? Those are all 5 times tables, so 5 is probably it. Or go to the littlest number, 1, 2, 5, 10. These are the only things that go into 10. Can 10 go into 30? Yes, but not 15, so no. Can 5 go into the other ones? Yep. And again, the check, to make sure you have the biggest one, take 5 into 10 goes twice, 5 into 15 goes 3, 5 into 30 goes 6, and ask yourself, can I divide all of the numbers in that list by anything? No, you really can't. You can divide these by 2, you can divide those by 3, but no, there is no common number that everything can still divide by, so 5 is the winning answer. That's factors, greatest common factors. The homework is entirely in the back. There's only one page, one location where the homework is found today. It's set F. Set F goes from 1 to 25. The first 10 are making factor lists the way we did in the first column. The next 15 are greatest common factors the way we did in this part. If you have confusion, email me. We'll set up a Zoom sometime.